Hello students, welcome to the session. In the previous video, we have discussed some of the basic concepts of joint priority, marginal priority, and some of the concepts like covariance, correlation, expected value of xy, and so on. Now in this video, let us discuss some of the examples on joint priority distribution. First, let us take the first example that the joint priority distribution of two random variables is given by, in this case they are given the joint priority distribution two variables x and y, and x takes the two values namely 1 and 2, and y takes namely the four values namely -2, -1, 4 and 5 with respect to priorities 0 0.1, 0 0.2, 0, 0.3, next 0 0.2, 0 0.1, 0.1, 0. And point 1 means it is the joint priority that the variable x takes the value 1 and the variable y takes the value -2. Point 2 is the probability that the variable capital X takes the value 1 at the same time the variable y takes the value -1. And now if I take this point 2, it is a joint priority that the variable capital X takes the value 2 and the variable y takes the value -2. Like that we can understand the joint priority concept what you have explained earlier. Now, for the given joint distribution, the first question is we have to find the marginal distributions of x and y. Now we have to calculate the coefficient of correlation between the two variables x and y. Now in order to find the joint priority distribution, in order to find the marginal priority distribution, first of all, for a given joint distribution, we have to take the row total as well as column total. First, let us write the joint distribution as it is. Now, let us take the row total as well as column total. Once you go and take the first row total, that is 0.1 plus 0.2 plus 0 plus 0.3, that results in 0.6. And the second row total results in 0.4. Now, similarly, the first column total results in 0.3. The second column total results in 0.3. And the third column total results in 0.1. And the fourth column total results in 0.3. Now, what are these row totals and column totals? The row totals indicates the marginal priorities of the values of x, and the column total represents the marginal priorities of the variable y. That's why we can write the marginal distribution of x as well as marginal distribution of y in this fashion. Now, as we know, x takes namely the two values 1 and 2 we have written, and the corresponding marginal priorities are given by the total in front of those values. The total in front of that 1 is 0.6 that we have taken here, and the total in front of that 2, that is 0.4 we have written and here, and this will represent the marginal distribution of x, and we can observe the total of that one is 1. Since next they ask the correlation coefficient, for that we need some of the values. Let us calculate them here itself, because for correlation coefficient we need expected value of xy, expected value of x, expected value of y, expected value of xy, standard deviation of x, standard deviation of y. For those, let us go for some calculation with respect to this table. First, let us calculate x into p of x. X is here, p of x is here. Once you take the product, 1 into 0.6, that is 0.6, 2 into 0.4, that is 0.8, the total results in 1.4. Now if I take x square into p of x, already x into p of x is there. If you multiply once again by x, it will give x square into p of x, that is 1 into 0.6 is 0.6 and 2 into 0.8 is 1.6, and their total results in 2.2. Now this is all about the marginal distribution of x and some calculation with respect to that which requires further. Now let us write the marginal distribution of y. Now marginal distribution of y means first of all we have to list the values taken by y. In this case the values taken by y are -2, -1, 4, 5 that we have listed, and now we have to list out the corresponding probabilities, and we have told the corresponding probabilities are given by the total in front of those values, therefore in each column. Therefore the total in front of this -2, that is the total of the first column, that is 0.3 we are written here. Next, the total in front of this minus 1 in this column is 0.3 that we have written here. The total in front of 4 that is in this column is 0.1 that we have written here. And the total in front of 5 that is 0.3 in this column we have written here. And this represents the marginal distribution of y. And again, once you look at the total, it results in 1. And we need some of the values in future with respect to the available table, what we call it as marginal distribution of y. Let us calculate some of the values. Okay, first let us concentrate on y into p of y. That is minus 2 into 3, that is minus 6, minus 1 into 3, that is minus 3, 0.3, that is 4 into 0.4, that is 1.6, sorry, 4 into 0.1, that is 0.4. Next, 5 into 0.3, that is 1.5. Once you take the total of these, that results in, that is 1 we can say. Now, similarly, once you go for y square into p of y, already y into p of y is available. You multiply that one by y again. That is the minus of minus becomes plus 2 into 0.6, 1.2. Minus of minus plus 1 into 0.3, that is 0.3. That is 4 into 0.4, 1.6. That is 5 into 1.5, that is 7.5. And the total of this one leads to 10.6. Now let us calculate some of the things which are required further. Let us concentrate on expected value of xy, which is given by total of x into p of x, and the total of x into p of x we have it as 1.4, and expected value of x square is total of x square into p of x. Summation means total of x square into p of x. As we know, the total of x square into p of x is 2.2. In the similar fashion, expected value of y is total of y into p of y, that is 1, and expected value of y square is total of y square into p of y, that is 10.6. Now, standard deviation of x is given by expected value of x square minus expected value of x whole square. Once we calculate this using these two values, it results in 0.49, and expected value of y is, standard deviation of y is given by square root of expected value of y square minus expected value of y whole square, and that results in 3.1 using these values. Now, expected value of xy we have to calculate the covariance. Therefore, it is given by double summation xy into p of xy. This is a way of writing mathematically, but the way of understanding is it is the product sum of all the possible x, y, and p of xy, that is joint properties. Now look at the joint properties here. Now we have to get all the possible product sum of x, y, and all the possible product sum of x, y, and corresponding joint properties. First one, 1 into minus 2 into 0.1, that were written here. 1 into minus 2 into 0.1. Next one, 1 into minus 1 into 0.2, that is 1 into minus 1 into 0.2. Next, 1 into 4 into 0, that is 1 into 4 into 0, plus 1 into 5 into 0.3, that is 1 into 5 into 0.3. Next one, 2 into minus 2 into 0.2, that we are written here. Next, 2 into minus 1 into 0.1, that is here. Then 2 into 4 into 0.1, that is here. Then it is 2 into 5 into 0, that is here. That means here, in order to find the expected value of xy, we have to take the product of all the possible x, y, and their joint properties, and we have to add all those probabilities. In this case, once you add all these, it results in 0.9. Once you simplify this, definitely it results in 0.9. Now we have to calculate correlation coefficient, but correlation coefficient is defined as covariance of xy divided by standard deviation of x into standard deviation of y. Keeping these things in mind, we have calculated some additional calculations earlier already. Therefore, we already know sigma of x, sigma of y. We have to calculate covariance of xy, and covariance of xy is given by expected value of xy minus expected value of x into expected value of y. And covariance of expected value of xy is covariance of xy is given as expected value of xy, that is 0.9, minus expected value of x, that is 1.4, and expected value is 1. Once you simplify, it results in minus 0.5. If we take covariance of xy is equal to minus 0.5, and standard deviation of X as this one already calculated 0.49, and standard deviation of Y, that is calculated as 3.1. If you calculate this one, definitely it results minus. Here minus is not written, please do take this one into minus of 0.3292. That will be the value we can say it is the required value of the correlation coefficient. Now let us go with one more example. They are given the joint probability distribution of two random variables x and y as follows. They are given the two joint probability distribution of two random variables x and y. In this case, x takes the two values, namely 1 and 2, and y takes the values 2, 3, and 4. And the question is, determine the marginal distributions of x and y and verify that r, x, and y are independent. Now first let us find the marginal distributions of x and y. In order to find the marginal distribution of x and y, first let us take the row total, each row total and each column total for the given joint distribution that we are written here. And this one is the joint property that x takes the value x1, y takes the value y1. That is p11, p12, p13, p21, p22, p23. That we can denote like that. Now the first row total is 0.3, the second row total is 0.7, the first column total is 0.2, the second column total is 0.5, and the third column total is 0.3. It is not 0.3, it is 0.3 that we can see. Now we can write down the marginal distribution. The marginal distribution of x means it is the list which shows the values taken by x, that is 1, 2, with corresponding properties. The probabilities are the totals input of those values. The first row total is 0.3 that we have written here, and the second row total is 0.7 that we have written here. Now coming to the marginal distribution of y, and first let us list out the values taken by y. It takes namely three values, y1, y2, y3, namely 2, 3, and 4 that are listed here. The corresponding probabilities are this is 0.2 and this is 0.5, and next one is this is 0.3. Here point is not there, it will be 0.3. Again we can observe the total of the marginal probability is 1. Now in this case, we have to verify that the variables x and y are independent. We say that the two variables x and y are independent only when p of xi yj equal to p of xi into p of yj, what we have already claimed here. That is, the two variables x and y are independent whenever p of xy equal to p of x into p of y. The same thing we can use here, and we can claim that the two variables x and y are independent only when p of xi yj equal to p of xi to p of yj for all ij. It should satisfy not only for few ij, it should hold good for all ij. Now let us consider p of x1 into p of y1. P of x1 is here, and let us do this as x1, x2, this as y1, y2, y3. P of x1 is 0.3, P of y1 is 0.2. That is 0.3 into 0.2. That will be 0.6. That is nothing but P11. I think that is here. But that x takes the value x1, y takes the value y1. That is P11. Now consider P of x1 into P of y2. That is 0.3 into 0.5. That is 0.15. That is nothing but P12. Now similarly, P of x1 into P of y3, that is 0.3 into 0.3, that is 0.09. That will be P13. Like that, we can find that P of xi yj equals to P of xi into P of yj for all ij. Therefore, we can conclude that the variable x and y in this case are independent variables. Now they are given one more example like this. The joint distribution of two random variables x and y are given by the following joint probability mass function, and it is given by p of xy equal to c into 2x plus y, where x takes the values between 0 and 2 both including, and y takes the values between 0 and 3 both including, and equals to 0 otherwise. And here they asked to find the value of c. And next, the marginal distribution of x and y. Then you have to find the probability that x takes the value 1 and y takes the value 1. And they asked to find the value probability of x takes the value greater than or equal to 1 and y takes the value which are less than or equal to 2. First, for these values, let us construct the joint probability distribution. In this case, as we know, x takes the values between 0 and 2, both including, that's why I have taken 0, 1, 2. And y takes the value between 0 and 3, both included. That's why here y takes the value 0, 1, 2, 3. In this function, when you take x equal to 0, y equal to 0, we get 0. When you take x equal to 0 here and y equals to 1, that is 1 into c, that we get c. When you take x equal to 0, y equal to 2 here, it will give 2c. When you take x equal to 0, y equal to 3, it will give 3c. Now, when you take x equal to 1, y equal to 0 here, it will give 2c. Next, 1 and 1, 3c, 1 and 2, 4c, 1 and 3, 5c. Like that, we can get all the values which are joint properties. Now, let us take the total of each row as well as column. Therefore, each row total, that is, this gives you 6c and this gives you 14c and this gives you 22c. Similarly, column wise also we get this one, and the total seems to be 42c. And we know one of the property that the total of the joint properties must be equals to 1. Once you add all these, we get the total of joint properties as 42. That's why total of joint properties is 42. Okay, that's why, and it has to be equated to 1. That is 42c equals to 1. That indicates c equals to 1 by 42. And when we take c equals to 1 by 42 here, we are going to get this one as 6 by 42, 14 by 42, 22 by 42. In the same fashion, we can get here 6 by 42, 6 by 42, 9 by 42, 12 by 42, 15 by 42. Now the marginal distribution of x. Now first let us list the values taken by x. They are 0, 1, 2. And the total in front of those values are 6 by 42, 14 by 42, 22 by 42. This represents marginal distribution of x. In the same fashion, marginal distribution of y we have to list out. And in this case, the values taken by y are 0, 1, 2, and 3. And the values, the totals of first column, second column, third column, and fourth column respectively are 6 by 42, 9 by 42, 12 by 42, as well as 15 by 42. This is the marginal distribution of y. Definitely, once you take the totals of each marginal distribution of x as well as y, they results in 1. And later on, they asked one more thing, that probability that x takes the value 1 and y takes the value 1. That means probability of p x equals to 1 and y equals to 1. And now once you come for this, when x takes the value 1, y takes the value, and the joint probability is 3c. When x takes the value 1 and y takes the value 1, the corresponding probability is 3c. That is 3c. And we have the value of c as 1 by 42. Therefore, that results in 3 by 42. And once you simplify this, that becomes 1 by 40. Now, the second one, we want probability of x is greater than or equals to 1 and y is less than or equal to 2. Now, let us give the permissible values for x, where x is greater than or equal to 1. Greater than or equal to 1 means x can take two values, namely 1 and 2. At the same time, let us choose the permissible values for y when y is less than or equal to 2. Less than or equal to 2 means it takes three values, namely 0, 1, and 2. Therefore, the values taken by possible values for y are 0, 1, 2. Now, let us take all the possible combination. When x takes the value 1, y takes the value 0. We can write it as p of 1, 0. Plus, when x takes the value 1, y takes the value 1. That is p1, 1. When x takes the value 1, y takes the value 2. It is p1, 2. Then it is when x takes the value 2, y takes the value 0. That is p2, 0. Similarly, p2, 1. Then it is p2, 2 we can write. And this p10, that is the joint probability that the variable x takes the value 1, y takes the value 0. When you come here, when x takes the value 1, y takes the value 0, it is 2c, that you are written 2c here. Next, 1, 1. When both are taking the values 1 and 1, its value is 3c. Okay, when 1 and 2, when x takes the value 1, y takes the value 2, it is 4c, that you are written here. Then when it takes the value, x takes the value 2, y takes the value 0. When x takes the value 2, y takes the value 0, it is 4c, that we have written here. Similarly, when x takes the value 2, y takes the value 1, okay, it is 5c. And last one is 2, 2, that is 6c. Therefore, once you add all these, that is 2 plus 3, 5, 9, 13, 18, 24c, and c is 1 by 42. We get it as 24 divided by 42, or we can say 8 by 14 or 4 by 7. That is the probability that the variable x takes the value greater than or equal to 1 and y takes the value less than or equal to 2. That is the required solution. Now let us go with one more example, which is different from the examples what you have constructed. The difference is, in the previous problem, the joint distribution or the joint probability function is readily available, and in this problem we hope so we supposed to construct that using the given information. And the problem is like this: a fair coin is tossed 3 times. X denotes 0 or 1 according to head or tail occurs on the first toss, and let Y denotes the number of tails which occurs. Determine the marginal distribution of X and Y. Second one, the joint distribution of X and Y. And the third one is expected value of xy, covariance of xy, correlation coefficient between x and y, and the expected value of x plus y. And here, instead of giving directly the joint product distribution, they are given one experiment and some information about that experiment, and we supposed to construct the joint product distribution for this particular problem. And now the experiment, they have given it as a fair coin is tossed 3 times. Tossing a fair coin 3 times is as good as tossing 3 coins at once. Both are leading the same sample space. That's why here when a coin is tossed 3 times, the sample space is. And here we have written all the 3 times it may result in head. First 2 times it may result head, third time it may result tail. First time head, second time tail, third time head, first time tail, second and third time head, all the 3 times tail, first 2 times tail, third time head, first time tail, second time head, third time tail, first time head, and second and third time are tail. And therefore this is the sample space we can get when we toss a coin 3 times or 3 coins are tossed at once. In this case, we observe that the sample space consists of 8 possible equally likely outcomes that we have listed here. Here n equals to 8. Now for each of these sample points, let us write down the values taken by x and y. Okay, and in this case, the values taken by x and y are going to be like this. First, let us note the sample space. Based on the sample space, we can write down those. There will be a slight correction in the statement of the problem. Here we have written y denotes the number of tails, but actually it represents the number of heads which occur. Okay, this is the instead of tails. Please refer it as heads. Now we have written the sample space like this, and now let us write the values taken by x and y for each of these sample points. Okay, as x denotes 0 or 1 according to the result head or tail on the first toss. That's why the result of the first toss is highlighted there. Out of 3 tosses, the result of first toss is highlighted in each sample point. Here it is head. When it is head, its value is going to be 0. That's why here head is there, it is 0. Here head is there, it is 0. First toss, head is there, it is 0. Here it is tail. When it is a tail, okay, its value is going to be 1. That's why it is 1. Tail is there, 1. Tail is there, 1. Tail is there, 1. And here it is, a head is there. Therefore, it is 0. Now, let us denote y. Okay, and they have said y as number of heads. As here we have written it as tails, but as I told you, please refer it as heads. Now, in the first sample point, we find 3 heads. That's why it is 3. In the second sample point, we find 2 heads. It is 2. For the third sample point, again, we find 2 heads. In the fourth sample point, there is only 1 head. Sorry, in the fourth sample point also, there are 2 heads. In the fifth sample point, all are tails. That's why here, no heads. In the sixth sample point, 1 head. In the seventh sample point, 1 head. In the eighth sample point, it is 1. And this table gives the values taken by X and Y for each of the sample points. And one more time, I remind you, please you refer this one as heads rather than tails. And now the possible values that X can take. As we know, once you look at the values of X, the possible values of X are 0 and 1. And the possible values of Y are, it may take 0, it may take 1, it may take 2, or it may take 3. Therefore, the possible values for Y are 0, 1, 2, 3. Now, the marginal distribution of X we can write. And now, the marginal distribution of X, that is, X takes the value 0 or 1. Now, as we know, probability means favorable by total, as it is indicated that total possibilities are 8. Therefore, now I'll write 8. Now 0. Now in this one, in this case, let us count how many times we may get 0. It is 1, 2, 3, 4. 4 times. These are 4 favorable outcomes for x equals to 0. That is 4 by 8 we can write. In the same fashion, x equals to 1. Again, we can find x equals to 1 4 times, therefore 4 by 8. That will be the required property for x equals to 1. Again, once we get the total, it results in 1. Now, again, we need a correlation and other things. Now, let us calculate some more values here itself. Now, let us calculate x into p of x. 0 into something, that is 0. 1 into 4 by 8, that is 4 by 8. Its total is 4 by 8, that is equals to 1 by 2. Now x square into p of x. Already x into p of x is here. For that, if you multiply by x, that is 0 into 0, that is 0. 1 into 4 by 8, that is 4 by 8. Again, it is 1 by 2. Now expected value of x is total of x into p of x. That is x into p of x is 1 by 2, that is 0.5. Expected value of x square, that is given by total of x square into p of x. It is total of x square into p of x is again 1 by 2, again it is 0.5. And the standard deviation of x is given by square root of expected value of x square minus expected value of x whole square. Once you take the square using these values, if you compute this, it results in 0.5. Now, as we know, the values taken by y are, it may take 0, 1, 2, 3. First, let us write the values taken by y. And we know n equal to 8. That is generally probability is obtained by m by n. M is the favorable, n is the total. And we know already total is 8. That's why for each denominator we have written 8 first. Now, among the values of y, let us see how many times it will take a value 0. Therefore, 0 can be observed only once. That's why its product is 1 by 8. Now, 1. 1 can be observed in the values of y list. It is observed 3 times. Its product is 3 by 8. Now, 2 again can be observed 3 times. And 3, it can be observed 1 time. Therefore, these will represent the corresponding properties of y. With the basic concept of probability, we have written this, that is, probability is given by favorable by total. Again, the total marginal properties is equals to 1. Now let us calculate y into p of y. 0 into 1 by 8, that is 0. 1 into 3 by 8, 3 by 8. 2 into 3 by 8, 6 by 8. 3 into 1 by 8, that is 3 by 8. The total is going to be 12 by 8, that is 1.5. And let us calculate y square into p of y. that is 0 into this, that is 0, 1 into 3 by 8, 3 by 8, 2 into 6 by 8, that is 12 by 8, 3 into 3 by 8, that is 9 by 8. Once you calculate, it results in 24 by 8, that is equals to 3. Now calculate expected value of y, which is required further. Okay, expected value of y is given by total of y into p of y, or summation of y into p of y. Total of y into p of y is 1.5, that you have written here. Expected value of y square is total of y square into p of y, that is total of y square into p of y, that is 3. Now sigma y is given by square root of expected value of y square minus expected value of y whole square. That will be 0.666 we get there. Now let us calculate the joint properties. The joint properties are given like this. P11 means it is the probability that the variable x takes the value x1 and the variable y takes the value y1. Now as we know, x1 value is 0, y1 value is 0. Now, once as we know, total property, in general property is given by m by n, and n is already known, it is 8. For each denominator, first let us write 8 there. Then let us go and calculate the variable outcomes, that is numerator, where we find 0 and 0 for x equal to 0 and y equal to 0 in this table. I think none of the time x and y together takes the value 0, means that is an impossible event, means 0 times we are going to find that is 0 by 8 is equal to 0. Now p of 1 2 means property of x equal to x1 and y equal to y2. That is x takes the value x1, that is x1 is 0, y1 is 1. That we can set as. Now in the table here, you look at the value when x takes the value 0 and y takes the value 1. Here x takes the value 0 but y is 3. Here 0 2. Here it is 0 2. And here these are 1. X takes the value 0 and y takes the value 1. This is only the favorable outcomes. Therefore it is given by 1 by 8. Now when x takes the value 0, y takes the value 2. When x takes the value 0, y takes the value. These are the two cases in which x takes the value 0 and y takes the value 2. Therefore it is 2 by 8. Now 0 3. When x takes the value 0, y takes the value 3. It happens only one time. Therefore that is 1 by 8. Now x takes the value 1, y takes the value 0. You can look at this table, and when x takes the value 1 and y takes the value 0, this is the only one case where we observe x is 1 and y is 0. That's why it is 1 by 8. Next, when they both are taking the values 1, and once you look at this, these are the two cases where x is 1 as well as y is 1. Therefore 2 by 8. Now x is 1, y is 2. X is 1, y is 2. I think this is the only one case where we find x is 1, y is 2. Therefore it is 1 by 8. And now x is 1, y is 3. I think it will not be here. X is 1 here. In none of the cases, y is 3. Therefore that means 0 times we get that 0 by 8. That will be 0. This particular thing represents the way of computing the joint properties. Now let us write them in the form of a joint property distribution. That is, x takes two values 0 and 1. Y takes four values, namely 0, 1, 2, 3. And we go on written P11. That is 0, 0. That is 0. Next 0, 1, 0, 1. It is 1 by 8. 0, 2. It is 2 by 8. 0, 3. That is 1 by 8. Next 1, 0. That is 1, 0. 1 by 8. Next 1, 1. That is 1, 1. 2 by 8. 1, 2. That is 1 by 8. 1, 2. That is 1 by 8. 1, 3. That is 0. No, after computing this, already we have computed marginal of x as well as marginal of y along with some of the requirements. Now only one thing is required, that is expected value of xy. That is, it is given by, it is product sum of all possible values of x, y and their joint properties. And we can calculate here this into this into this, that is 0. This into this, that is 0. This into this, that is 0. this into this, that is 0, this into this, that is 0. Okay, now 1 into 1, 1 into 2 by 8, that is 2 by 8, that is 1 into 2, that is 2, 2 into 1 by 8, that is 2 by 8, that is 1 into 3, 3 into 0, that is 0. And if you add these, that becomes 4 by 8, that is 0.5. Now, once you look at the requirements, we have calculated marginal, we have calculated joint, now we have calculated expected value of xy. Now let us calculate covariance of xy. It is given by expected value of xy minus expected value of x into expected value of y. Expected value of xy just now we have calculated, it is 0.5 minus expected value of x is 0.5, expected value of y is 1.5, and that results in minus 0.25. Okay, and there might be some calculation mistake is there. And expected value of xy is 0.5 and expected value of x is 0.5 and expected value is 1.5. Once you calculate its value is going to be minus 0.25, and correlation coefficient R is given by covariance of xy divided by standard deviation of x into standard deviation of y. And covariance of xy, so far we got it as minus 0.25, and standard deviation of x is 0.5 and standard deviation of y is 0.866. Once you simplify this, it will result in minus 0.5774. And now expected value of xy is one more requirement, and it is given by expected value of x plus expected value of y. Once you take the expectation inside, we get this, and expected value of x is 0.5, that is we have calculated here. Expected value of y is 1.5, and there the sum results in 2. That will be the expected value of xy. Therefore, this is all about the problem where so many things we have calculated, right from marginal distribution, joint distribution, expected value of xy, covariance, correlation, as well as expected value of x plus y. One more go with the last problem, and here also the joint product distribution is not given, and we have to construct based on the given information. And the problem statement is like this: two marbles are drawn from a box containing 3 blue, 2 red, and 3 green marbles. If X denotes the number of blue marbles and Y denotes the number of red marbles drawn, then find the joint distribution of X and Y, the marginal distribution of X and Y, then expected value of X and expected value of Y. And first, let us denote X. They have given X represents number of blue marbles drawn. That is, X denotes number of blue marbles drawn, and Y denotes the number of red marbles drawn. As we are drawing two balls, okay, from the box, okay, then what are the possible values that X can take? Now, in the selection, there may not be any blue ball. In that case, X takes the value 0. There may be one blue ball, or sorry, blue marble, or there may be two blue marbles. These are the possible values that X can take. In the same fashion, when we draw two marbles, in the selection, there may not be any red marble. In that case, Y takes the value 0, or there may be one red marble, or there may be two red marbles. These are the possible values that the variable Y can take, where Y represents the number of red marbles drawn and X represents the number of blue marbles drawn. And as the information says, in the box there are 3 blue, 2 red, and 3 green. Therefore, overall there is 3 plus 2 plus 3. Totally there are 8 marbles in the box. Now we are drawing 2 marbles. Out of 8 marbles, any 2 marbles can be drawn in 8C2, that one equal to 28 ways, and this represents N, that is total number of equally likely cases. There are 28 ways of drawing 2 marbles out of 8. Now, as we let us go on write the joint distribution, we have to calculate that one. In this case, x takes the value 0, 1, 2 that we have written here, and y takes the value 0, 1, 2, where x represents number of blue marbles drawn and y represents number of red marbles drawn. And from the given information, we have there are 3 blue marbles, that's why we have written blue equal to 3 and red equal to 2. When we say x takes the value 0 and y takes the value 0, means as we know, we are drawing two marbles. In those two marbles, there are no blue balls, there are no red balls or no red marbles. Okay, that means, okay, whatever the two marbles we draw, they must be green. And how many green are there? Out of 3, any 2 can be drawn in 3C2 ways. Therefore, 3C2, that is a favorable, and already we know the total as 28. Next one, x is 0, means no blue and 1 red. Out of 2, 1 red can be drawn in 2C1 ways. At the same time, one more, when there is no blue, there must be 1 green. Out of 3, we have to draw 1 that can be drawn in 3C1 ways. Now, x is 0, means in the selection, no blue, but 2 must be red. Out of 2 red marbles can be selected in 2C2 ways, and total possibilities are 28. And here we are writing the probabilities using the concept of m by n. It is favorable divided by total. Now coming to the next one. 1 blue and no red. Out of 3, 1 blue can be drawn in 3C1 ways. Since no red balls means the other one must be green. Out of 3 green, 1 can be drawn in 3C1 ways, and total is 28. And again 1 blue. Out of 3, 1 blue can be selected in 3C1, and 1 must be red. Out of 2, 1 must be red. That is 2C1. And now 1 blue and 2 red. 1 blue and 2 red, that means 3 balls. It is not marbles. It is not possible, because at the most we are drawing 2 marbles. Therefore, it is an impossible event. That's why its probability is 0. Now coming to this, 2 blue and no red. 2 blue out of 3, 2 can be drawn in 3C2 ways. No red means it will be left out. Or divided by 20 is there. And 2 and 1, again 3 balls, it is impossible. And 2 and 4, 2, 4 balls, again it is impossible event. And this will represents the joint distribution. And in order to find the marginal, now let us go for row total as well as column total after calculating these combination values. Now 3C2, x takes the value 0, 1, 2, y takes the value 0, 1, 2. 3C2 is 3, 3 by 28, this is 3 into 2, 6 by 28, this is 1 by 28, this is 9 by 28, this is 6 by 28, this is 0, this is 0, this is 0, and this is 3 by 28. Once you go for each row total as well as each column total, we'll get this. Now, once we get the each row total as well as each column total, we can calculate the marginal distribution. Now, let us write the marginal distribution of x. Now, x takes the values 0, 1, 2, and the probabilities are nothing but the total in front of those values, that is 0, 1, 2. They are the values taken by x, and the corresponding values are given by 10 by 28, 15 by 28, 3 by 28. They are the row totals. Now coming to the marginal distribution of y, here also y takes the value 0, 1, 2, and each column total will represent their marginal totals. Therefore, it is 15 by 28, 12 by 28, 1 by 28. These represents the marginal totals of marginal distributions of the variables x and y. Now they ask to find expected value of x, that is total of x into p of x, that is this into this, that is this into this, that is this into this, that is this. And its calculation leads to 21 by 28. And now expected value of y is this into this plus this into this plus this into this. That results as 1 by 2. Now these are the requirements with respect to the given problem. And this is one problem. Try to work out this. We titled it as practice problem, and they have given the joint distribution of the two variables x and y. In this case, x takes the values 1 and 5, y takes the values -4 to 7. And here we are required to find the marginal distributions of x and y, covariance of x and y, correlation coefficient between x and y, and we have to find the property that x plus y is greater than or equal to 3. And this one, these can be calculated using the reference of the previous set of problems. And the last part here, try to give the possible values for x and y so that the sum must be at least 3 or more values. So try to find such possibilities and add the corresponding probabilities. Okay, this is all about the examples on that joint distribution, priority distribution. And here we will discuss 4 to 5 problems and try to practice this problem. If you find any doubt, let us discuss further. Thank you.